The equipment in a power plant or substation is expensive. Expensive to buy and install, and expensive if it remains out of service for any length of time. One danger to plant and equipment is fire. Not the planned, controlled infernos that heat, feed water, and create energy-rich steam, but the unexpected, undesired fire, large or small, which is a potential destroyer of equipment, property, and even people. Designers and safety engineers spend much time and money in providing fire protection for the plant and utility properties. However, unless it is used properly, no amount of fire protection equipment can stop an unwanted fire. Improper use of fire equipment can often do more damage than the fire itself. More important, especially in electrical areas, improper use of firefighting devices may be dangerous to the user. Types of equipment and usage vary from one station to another, and even may vary in a single plant. This film will only examine basic principles of fire safety. The specifics you will learn as part of plant safety, training, and drills. Now, it may sound corny, but it's true that the easiest way to avoid fire damage is to prevent a fire. Small oil leaks should be reported at once and corrected before they become fuel for a fire. So should a hot-smelling electrical box or device, or any smoking insulation, even if the circuit is cut off. Careless human habits and failure to observe posted fire regulations are hazards which should be corrected before they cause trouble. Fires are normally classified by type and designated with letters A, B, or C. Let's look a moment at each type. Most of us are familiar with the common Class A fire. It's fueled by paper, wood, leaves, glass, rags, or trash. Good housekeeping can prevent Class A fires. Water is an effective and safe way to extinguish most Class A fires. Other extinguishers may be used on a Class A fire, including the soda acid type, foam type, and pressurized water type. For larger fires, large quantities of water are usually necessary to cool the entire fire area and prevent further combustion. But even water hoses must be used with care and thought. Some materials, such as insulation, grease, oils, paint, and varnish, burn easily and spread rapidly. These oily fuels create and spread further. Class B extinguishers act by smothering the fire, that is, cutting off the oxygen needed for continuing combustion. This may be done with dry chemicals, CO2, foam, or vapor-type extinguishers. Perhaps of particular interest to utility people is the Class C fire, which is caused by or associated with live electrical equipment. A Class A or B fire becomes a Class C problem if it's located in an area close to live electrical equipment. Cutting off all power can change the fire balance. Class C fires present two dangers, the fire itself and the danger to the electrical power. To fight these, we must use smothering type materials, which will not conduct electricity. Carbon dioxide, CO2, certain vapors, and dry chemicals are usually effective. Never use water on an electrical power fire. By smothering a fire with gas or vapors which prevent oxygen from reaching the fuel, we effectively choke off the fire. Carbon dioxide, or CO2, is a component of the air we breathe, but because the oxygen in it is not free to burn, it will not sustain combustion. It's also heavier than air. Just as light gases like helium cause a balloon to float upward, a balloon full of CO2 would settle to the ground very quickly. Carbon dioxide, then, can act to blanket or smother a fire as long as it's applied from above. Some extinguishers contain a non-burning, non-conductive liquid which rapidly vaporizes when released to form a choking blanket of vapor over the fire. There are several types of dry chemical extinguishers. Most of these rely on heat near the fire to cause dry powder to vaporize. This smothers the fire and only works where there's heat. No wise person would knowingly hold a stream of water on a high-voltage electrical source, but we may on occasion use one form of water for Class C fires. In outdoor areas where CO2 or vapor might easily be blown away, special fogger nozzles create millions of tiny water droplets which can cool and even smother the burning materials. As long as it remains fog, water does not act as a conductor. Large outdoor equipment may be surrounded by fogger nozzles, which can be remotely operated to blanket an entire area. Steam may also be used as a type of fire protection, similar to water fog, but must not be used where people might be present. To prevent possible freezing or plugging of fire that part of the system, later the entire system must be closed off and drained. When using a fire hose connected to a hydrant or fire header, be sure there are enough men on the hose to control it before the water is turned on. A 2-inch hose may be more than one man can control, and power from such a nozzle can be dangerous to all people in reach of the water. Be smart. Get help. When hoses have been used, even if only for a drill, proper attention must be given to coiling and storage to prevent holes or weakened spots within the hose. Many systems provide a booster pump to increase water pressure when needed. It may be necessary to call for, well, so much for water. Since carbon dioxide does a good job of smothering all classes of fire, it's little wonder that so many areas of the power plant are fire protected with CO2 devices. Comparatively thick-walled steel cylinders are used to contain carbon dioxide in liquid form for many extinguishers. At 100 degrees Fahrenheit, the vapor pressure is 1,465 pounds per square inch. Large tanks will not stand such pressures. But some plants store a quantity of liquid CO2 cylinders together, feeding a central firefighting system. If there were a way to keep the temperature low, even to keep vapor pressure reasonably low, a much larger quantity of liquid carbon dioxide could be safely stored. In fact, thanks to reliable refrigeration systems, a number of devices are available to store thousands of pounds of liquid CO2 efficiently and safely. This is the equivalent of more than 1,000 individual units. Specially fabricated pressure tanks containing the liquid CO2 are kept at temperatures well below zero by refrigeration. A dense insulation barrier and a steel housing covers the storage tanks. Safety devices monitor the pressure, and in the event of failure of the refrigeration, excess pressure will be safely vented away. When pressure is released, the liquid CO2 will expand at room temperature to fill a space about 450 times its liquid volume. So not many CO2 nozzles are needed to ensure coverage of large areas, as you can see. In a centrally supplied CO2 system, we may have both manual and automatic equipment. Hose reels with special CO2 nozzles are usually connected to a control device which opens supply valves when the hose is unreeled for use. Automatic system, for instance, is a maze of steam headers and valves, insulation, and oil lines. A leaky oil line could create a costly fire here. But CO2 nozzles automatically blanket the space in the event that thermostats detect a sudden increase in temperature. Automatic CO2 systems also include alarms and devices to indicate which sensors indicate a fire or excessive temperature. Usually, the alarm will signal 15 or 20 seconds before the CO2 valves open to warn people in the area the automatic system is about to open. Since the system is automatic, plant personnel should move to their proper emergency positions. Remember, the heavier CO2 gas that displaces the oxygen needed for combustion can also smother a person who remained very long in a room full of the gas. Most central CO2 systems also provide manual operating controls. These sound the warning alarm, then release a predetermined quantity of CO2 to blanket the area, and then they shut off again. This is known as momentary or automatic discharge. Systems with manual or spurt control buttons also allow an operator to direct more CO2 if the fire is not completely extinguished. Remember, too, that expansion of liquid CO2 when it leaves a nozzle can create a frost that should not be handled without gloves. Frostbite's no fun. Actual operation of these extinguishers depend on both the type of system and the type of fire. That's one good reason for safety equipment classes and fire drills in which plant personnel have opportunities to practice with different types of extinguishers and special equipment. Gas masks and self-contained breathing apparatus, for instance, not only allow firefighters to get closer to fires, but may also aid in the rescue of other people. These emergency drills and training classes are an important part of your total job. After all, it may well mean saving your job and other lives in the event of a major fire. As you learn your job better, you'll more easily recognize conditions which could lead to a fire. That means good housekeeping and following safety rules. The fire which never gets started does the least damage, and of course it's easier to prevent a fire than to fight one.
At this time, stop the player and take the quiz in your power plant mechanical systems workbook for Fire Safety Systems. When you have completed the quiz, restart the player and we will review the answers together.
Let's see how you made out in your questions. The answer to number 1 is false. Fires are classified by what is being burned, not by the size or seriousness of the particular blaze. Improper use of extinguishers can be more damaging to equipment and to people than some fires are, so number 2 is true. 3 is false. No unwanted fire, class A, B, or C, is to be considered harmless until it's completely out. You should have marked number 4 false. Water is one of the best ways to combat a class A type of fire. If a class A or B fire spreads to include any live electrical circuits or equipment, it becomes class C. 5 then is true. 6 is false. Whenever practical, all electrical power in the area of a fire should be turned off as soon as possible. Tiny droplets of water in fog or steam can be used in some applications to fight fires. It is false. Since a dry header system should not contain water until the valves are opened, these systems are often used to avoid freeze-ups. 9 is true. The force of pressure and flow makes the 2.5-inch and larger hose systems too powerful for one man to handle by himself. Carbon dioxide may cool the fire a bit, but it's the smothering ability which does the most to stop combustion, so 10 is false. However, 11 is true. Even at 0, the vapor pressure of liquid CO2 is 300 pounds. Though CO2 is effective on all types of fire, it is the most recommended extinguisher on Class C fires, since it is non-conductive and leaves no residue. So, question number 12 is false. Number 13 should have been answered true. Most automatic fire protection systems sound a warning alarm to signal the fire and permit people to get out of the way before the extinguishing starts. Number 14 is also true. As long as we prevent fire from getting oxygen, we stop further combustion. Modern, properly maintained, and correctly used equipment is important to fight fires, but prevention means stopping fires before. Fires is a good way to protect our jobs and save lives. All of us must help around the plant.